involves different techniques in which we will utilize the methods, the principles to analyze any substance, right? So here we have seen potentiometry, conductivitymetry, etc. Now we will begin with pH meter. So pH meter or pH metry basically involves the study of pH which can be used for further identification. Here we will begin with pH and its measurement. So if we talk about its definition, then the concentration of the hydrogen ions and indirectly hydroxide ions are given by pH number, right? So pH can be defined as logarithm or negative logarithm of the hydrogen ion concentration. We can write pH is equal to minus log of H plus. This is very basic, which gives rise to the pH scale. Right? So if we talk about pH scale, then pH scale measures how acidic or how basic a particular substance is. The pH scale ranges from 0 to 14 and a pH of 7 is considered as a neutral. So I should say that from 0 to 6.8 is considered as slightly acidic, while 7.2 to 14 is considered as basic. So here this acidic and alkaline, both of this are the things that actually determines the nature of the substance. Okay, so we have to understand here that the pH, which is less than 7, is considered as acidic in nature, while the pH which is greater than 7 is considered as basic in nature. All the acids, HCl, H2SO4, hydrochloric acid, that means sulfuric acid, nitric acid, are considered as acidic in nature, while we have a negative ones, or we have the alkaline ones, which is NaOH, Na2CO3, NaHCO3, are considered as alkaline in nature. So we can differentiate acids and bases on the basis of all these things. Okay. Now pure water is considered as neutral, but if certain contaminations are there in the pure water, then it is considered as either acidic or basic. It will turn acidic or basic depending upon that. Okay. Now let's begin with the examples of acidic substances. Acidic substances are the substances which has the pH less than 7. So vinegar or lemon juice is considered as acidic in nature. Lemon juice, basically it contains citric acid, it is acidic in nature. Similar way, we have milk of magnesia, we have ammonia solution or normal ammonia gas are the examples of alkaline substances, or I should say the basic substances. Now next is pH meter. So pH meter or pH metry is the technique in which we will utilize the pH to identify any substance. Here pH meter is an electric device which is used to measure hydrogen ion activity, either its acidity, either its alkalinity in a solution. Fundamentally, a pH meter consists of a voltmeter attached to a glass electrode. Now the pH responsive electrode is usually made up of semi-permeable glass membrane. Here it contains, here as you can see, it's a saturated calamine electrode. Even we have a kind of glass electrode which has concentrated HCl which is filled inside a glass permeable membrane, but so it will observe the change in H plus ions between the solution and between the electrode. It will observe that particular pH change, and in that manner it will actually determine the pH of that particular solution. Okay, that is the base, that is the principle of pH meter with which it actually works. Generally, all pH meter works on that particular basis. Okay. Now let's move ahead to the application. So major end users are food science, pharmaceuticals, Biotechnology, Environmental Research and Pollution Center, and even others. These are very basic ones which actually involves the application of pH method. When we talk about any pH indicator, when we talk about pH paper or a normal titration, it will not give rise to a specific result. That means it will not give rise to a perfect result. And when we want any kind of perfection in our result, at that time we have to use the instrumental method. So to use or to get the perfect result, when we deal with this, then that particular instrumental method that we can utilize here can be a pH meter, it can be a potentiometer, it can be a conductivity meter, right? These are the methods, electroanalytical techniques which we can use, right? So similar way, pH meters are used to measure acidity levels in water and wastewater treatment, pharmaceuticals, chemicals and petrochemicals. So I should say that in almost each and every field, from petrochemical industry to pesticide industry to any other kind of pharmaceutical industry, chemical industry, food industry, research and development institutions or any higher education institutions, the most basic instrument that will be present in the laboratory will be pH meter. First and foremost, the pH of any solution has to be determined in order to further analyze it. So when we analyze it properly, then and then only we can get the results. So this is the basic one which we applied, and after that we will do further analysis or hyphenated analysis of any substance. Okay. Now let's move on and let's see what is spectroscopy. Right. So as I told you earlier, that spectroscopy deals with the production, the measurement and the interpretation of the spectra arising from the interaction of electromagnetic radiation with matter. Okay. Which is the important thing? That is electromagnetic radiation. Electromagnetic radiation, when it is imparted on any matter, at that time it shows you either absorption, any kind of scattering, any kind of emission, etc. And in that manner it gives rise to the identification of the substance. Okay. So identification of substance is basically depends upon what? The matter and the electromagnetic spectrum. These are the two things which are involved in it. Okay. So there are many different spectroscopic methods available for solving a wide range of analytical problems. We can actually have a huge field which is known as spectroscopy. Okay, the spectroscopy knows UV spectroscopy, IR, Raman spectroscopy, UV, IR combined, IR, Raman combined, and any others or sophisticated instruments are actually can be produced when we talk about spectroscopy. Right? Each and every one generally involves the interaction of light with matter, and here light means spectroscopy. So the spectroscopy is the meaning. Okay, it's a measurement of light. Measurement of light which is either absorbed, either emitted by the particular matter. Okay, this is the meaning of it. Now the methods differ with respect to the species to be analyzed here, such as the molecular or atomic spectroscopy, the type of radiation, the matter interaction to be monitored, such as absorption, emission or diffraction, and the region of the electromagnetic spectrum which is used in the analysis. So as I said earlier, two things plays a very important role. Number one, which is the matter which is involved. Number two, the electromagnetic spectrum which is used for the analysis. Because each and every analyte can't be analyzed using the single spectrum region. For different samples, you need to apply different regions. Okay, and in that manner, you will get to know about the particular identification of the compound. or else you will not get an idea about identification of that particular compound. Okay, this is how spectroscopy actually works. Now let's talk about the electromagnetic radiations. Electromagnetic spectrum consists of a huge amount or huge number of radiations. So here, if we talk about it, spectroscopic methods based on the absorption or emission of radiation in ultraviolet, in visible region, in IR region and in radio region. Frequency ranges are most commonly encountered in traditional food analysis laboratories. Okay? So depending upon ultraviolet region, the name which is given to UV is UV spectroscopy. The technique that came with the use of visible region is known as visible spectroscopy. Similar way, the technology which is for the spectroscopy which came into existence through the use of IR is known as infrared spectroscopy. Right? Similar way, we use radio waves in nuclear magnetic resonance spectroscopy. So different fields are used in different ones. Like microwaves are also used in microwave spectroscopy. These are the techniques with which we can actually analyze our substances. Okay, these are the methods with which we can use them. This is all for this session. Next we will see in our next